All right, good evening once again, students. It's good to see you once more. All right, so we're going to be continuing from where we left off in the previous class. And just to recap what we have done so far from the previous class, we would have done using the distributive law to remove brackets. And we saw that we have pretty much three rules that we need to pay attention to when we're removing brackets. So the general rule, which would be rule 1, when you have a number outside the bracket or slash a term outside the bracket, that term you take that term to multiply each of what is inside the bracket. And so you maintain whatever signs you have in the brackets once what is outside is a positive value. So that's applying the distributive law. All right. So the distributive law states that multiplication is distributed over a set of terms that are added and subtracted. All right. So we would have carried out that exercise and we would have learned how to do that first rule. So the second rule is that whenever you're distributing with a bracket and the term outside is negative, then what the result of that is whatever sign you have inside the bracket will change to the opposite when the bracket is removed. So once you multiply out distributively, the terms inside the bracket, the signs inside the bracket will turn to their opposite once you're multiplying by a negative term outside the bracket. So that was rule number 2. Rule number 3 was if you're given any form of expression in consisting of brackets, in order to simplify, first you remove brackets and you simplify by adding or subtracting like terms. And wherever you are through simplifying and then what you have remaining would be unlike terms, you keep those as an expression, meaning that you have the unlike terms with either plus or minus sign between them. So that becomes an expression where you cannot simplify that any further. All right. Now, today, what we're going to be looking at the product of two binomial expressions, sometimes referred to as binomial expansion.
2019 is the governance review of Crooked Western's operations. It is the fifth.
Now, the product of two binomial expression will lend itself to the same distributive property that we have been using. So, in other words, we will apply in a similar way the distributive law, but now instead of dealing with just one brackets times a term, now we're going to be looking at the product of two brackets. Now, the brackets that are the brackets that we have generally consist of binomial expression. So let us start off with that word, binomial. Anybody have any idea what the word binomial is? Miss Ashanti, have you ever heard the term binomial before? Are you responding, Miss Ashanti? I'm not seeing where you're responding.
No, sir.
All right. Ms. Cavero, binomial. Yeah. Would you like to share with us what you know about binomial?
No, sir.
Okay. All right. Anybody else? Any volunteer? Nobody would like to tell us what a binomial expression is? All right.
An expression consisting of two terms, sir. Considering the bi, which means two, I don't know, I'm just guessing.
Correct, Ms. Wilson.
Okay.
Yes. Thanks for that input as I was about to intervene. All right. So the word binomial, you see the word nomial, it really means the nomial kind of comes from the word name, but in this case, when we're saying binomial, we're really referring to an expression that consists of two terms. And we would have looked at before what the difference between an expression and a term. And I would be sure that my students are able by now to tell that difference. Anybody would like to remind us what's the difference between a term and an expression? You want to do the honors this way, son? So my question is, what's the difference between a term and an expression?
Sir, term by itself would have been like a general, hold on, sir, Miss will come again.
All right. All right, so in algebra, when we're referring to term, we're really referring to the variables. Either you have multiples of the variable, like say 2x, 2 would be a multiple of, we use 2 to multiply x, so 2 times x would be multiple of x. You want to say something now, Ms. Lisa?
Yes, sir, as you said, and then you said expression, sir. You did mention something about expression too, right?
Yes, I did mention expression.
Right, and then expression would have formed from the unlike terms, whether by adding with the additional sign or subtraction sign of two unlike terms.
All right, thanks much, Ms. Wilson. So adding to what Ms. Wilson just said, so the terms are generally either a multiple of the variable by multiplying it by a number, or a quotient of a variable, you're dividing it by a number, or you can also have just the variable by itself. And in that case, the coefficient would be 1. And remember, when we have a multiple of a variable, like say the variable x, if you're having a multiple of that variable, it simply means that you're multiplying it by a number, right? So when we say 2x or 3x, those are multiples of the variable x. And if we have just x, then the coefficient there would be 1. And so it is still, in a sense, a multiple. So we can have a multiple of the variable. And sometimes the variable might not only be a multiple of number, but you can have products of 2 or more variables. So you can have xy, and that also will be a term. So the moment though we're adding terms together, and once it is not simplified into a single term, what we have when we're adding and subtracting terms with the plus and minus sign between them is what we call an expression, right? And just to add to what Ms. Waysome was saying, Ms. Waysome was saying that unlike terms, when you add them or subtract them, because you cannot simplify them into a single term, they remain as they are with the plus or minus sign between them. And that entire addition and subtraction of the unlike terms, that entire thing now would become an expression. Now, it doesn't mean that we don't have expression with like terms. You may have 2x plus 3x, and that by itself would be an expression. So if it remains as 2x plus 3x without being simplified, it would be an expression. But generally, when we have expressions with like terms, we know that we can simplify them into a single term by just simply adding their coefficients. All right? So it doesn't mean that an expression has to be only with unlike terms. You can have an expression written with like terms. However, it would not be simplified. Is that clear to you all, students? Let me see your hands. All right, so back to what we're looking at for today. So we're looking at the product of two binomials. And Ms. Wilson would have confirmed already that a binomial expression is an expression consisting of two terms. And if we have here the product of two binomials, you know that when we are finding the product, we're actually multiplying things together. All right, so these are examples of binomial expressions. So each of these expression only has two terms. So this is one binomial expression. This is another binomial expression. This also, as well as this one. So these are all binomial expressions. Now, when we're thinking about the product, now it means that we're going to be multiplying one binomial expression by another binomial expression. Now, generally, if we are to find the products of expression, we will put the expressions in brackets, right? Now, by putting the expressions in brackets, we treat the expression as a single unit, all right? So a bracketed expression is treated as a single unit. So this is one binomial expression bracketed, and you can bracket this one, and then now by multiplying the two together, then you will be finding their product, right? So when we say the product of binomial expression, it means that we have one bracketed expression, one bracketed binomial multiplied by another bracketed binomial. Now, so here now we have the product of A plus B times C plus D. Now, as I had mentioned, each of these expressions bracketed now is treated as a single unit. So in other words, this entire binomial here, you could just treat it like a single variable. For instance, let's say that all of this would be x. And all of this binomial here, treat it like a single variable too. And you could call this one y. And so the product simply means that there is an invisible multiplication sign between them. And so you will have xy. Now, for the binomial, there are times when we are asked to remove the brackets. And in order to remove the brackets for two binomial products, we have to apply the distributive property. All right, so we would have been familiar with the distributive property from the previous class. So now, before we look at the product in terms of a distributive property, I want you to consider this diagram to see how the product, when you multiply them, what the result should be. All right. Now we are thinking about this rectangular shape, and we are thinking about finding the area of this rectangular shape. So this rectangular shape here, and notice that I'm not referring to it as a square because it is not a square. All right. Let me see if I can change that color. All right, so this rectangular shape. All right, so that's a bigger rectangle. Now you have this big rectangle that you notice here would have cut up into smaller rectangular shapes. All right. Now we are using this to illustrate. We're just using this to illustrate why when we multiply two binomial, what the answer we should get would be like finding the area of each of these rectangles. Now, so what we know in algebra, if we're using, if we're dealing with algebra, we're working with variables. So if we are measuring the length of the bigger rectangle, then this length, if you have a length from here to here, which is A, and if that length is extended by another length, B, then the entire length here would simply mean that the entire length is going to be A plus B. So this entire length here from here to here. So the length of the big rectangle would be A plus B. And likewise, when you look at the width, we see that the length of the width would have a length of C plus D. Now, generally then, if we are to find the area of this rectangle, we will multiply length times width. So in this case, the length is A plus B, the width is C plus D. So if we are going to multiply that, then clearly we would have to multiply A plus B times, so we'd have to multiply A plus B times this thing act up sometimes, guys. So A plus B times C plus D. All right, now, if we are to multiply this using the distributive property, there are a number of techniques that we can use. But remember, when we were doing the distributive property, if we have A outside the brackets, and then we have B plus C inside the brackets, when we are multiplying that out, we take the A, multiply the B, we get AB. Then we take the A again to multiply the C, but we're going to maintain what sign we have in the brackets. Once the term outside is a positive term, you keep the same sign that you have in the brackets. So we have now A times C, give you AC. And so this is how we would remove a bracket, or remove brackets with just a single term using the distributive law. But if we have the product of binomials, what you would notice with the binomial is that now both brackets have two terms. So if you're going to apply the distributive law, you're going to take each term in the first bracket and distribute them one at a time. So in other words, you're going to take the A first and use it to distribute in the bracket. So you go A times C, you get AC. So you get AC plus, use A again, times D, you get AD. And then now, after you have done the distribution with the A, then you now use the B and do the distribution once again. So you have B times C, so you have plus BC. So we have BC plus B times D. Now we would have BE. And that's how we actually apply the distributive law when we're doing a binomial product, right? So when you remove the bracket, then you should get all of these terms. You should get 4 terms from the expansion, right? Now, if you look at, when we compare it to this rectangle, when you multiply the 2 brackets, which is AB times CD, then you get AC, which representing this section of this rectangle. And if you look at it, you see it would be A times C, give you AC here, right? So if you find the area of this rectangle, then now when you get AD now, you would have, for this section, you have A times D. So this is the rectangle. And then now for BC, you would have this rectangle here. And I want you to just note that these rectangles would be as a result of these lengths. So this length A, and this length C, and this length B with this length C. So you should clearly see that if you cut up this rectangle based on these lengths A, B, and CD, you will get these smaller rectangles. And so when you find the area of the big rectangle is equal to the sum of the areas of these smaller rectangles. And by showing you that without the diagram, you can use the distributive property. So in other words, the distributive property of a binomial is really showing you how you could find the area of a rectangle if you know the length in terms of 2 variables. And then now, if you know the length of 2 variables, then you could cut that rectangle up into parts based on those lengths. So once you multiply out the bigger length, it should give you the sum of the areas of each of these smaller rectangles. All right, so that's the idea. That's a bigger picture behind binomial expansion. So when you're removing brackets of for two binomials and you're multiplying them, it really means that you're finding the area of a rectangle using the lengths based on cutting up the rectangles based on these individual lengths. Because the length of this one would be this length A plus this length B. And likewise, we have this length C plus this length D. But if you were to multiply them as expression, you should get the area of these smaller rectangles. And so that would give you the result from binomial product from a distributive law point of view. All right, so note that the area of the large rectangles is the sum of the areas of the smaller rectangles. All right, so using that without the diagram, we simply can multiply binomials without a diagram by following these properties. All right, so as I had mentioned before, you use the first bracket. Each term within the first bracket, you use them once to distribute in the second bracket. So using the A, you multiply distributively. So A times C, then A times D, right? Maintaining the plus sign here. So AC plus AD. Then now you use the B to do the next distribution. So B times C plus B times D. And so you get BC plus BD. And so this is a four-term expression. So when you expand or when you remove the brackets of two binomials, you should have four terms in your expressions. Now there are some cases where two of these terms may simplify to a single term, especially when you're looking at expressions that lead to what we call quadratic expressions. All right. All right. Any questions so far? Is it clear what I'm explaining to you guys? Any question? Escavero? Is it clear so far?
Yes, sir.
Let me see the hands of those who understand clearly what I'm saying.
Can you go over again, sir?
All right, so